Hello everyone, welcome. I see that Parvathy is already here. Hi, how are you?
Good. You?
Good, all good. I made you co-host, so I think you should be able to share your slides, or if you need me to do anything, please let me know. Maybe let's wait 5 more minutes or a few more minutes to see people coming in, and then we can start when you want. Okay, I think we can start if you're ready.
Yeah, I think it's good to
Perfect.
start. Do you see my screen, all of you?
Yes, we can.
Thank you so much, Martha. So, yes, this is the first time I'm presenting for this cohort, so I'm really excited and looking forward. I am Parvathy. I am the Chief Technology Officer at Analytics for a Better World Institute. And I'll give you a quick update on my journey so far, so you know a little bit better about me before we dive into the session. So I started my career in India, where I'm originally from. Currently, I'm based in Netherlands in the city of Eindhoven, but I started my journey somewhere here. So I did a bachelor's in electrical and electronics engineering, and then I worked for 1.5 years in an IT company where I picked up a bit of programming. And then I decided, okay, I want to do a master's in more in the renewable energy sector because, of course, of my bachelor's in electrical. So I decided to do an MTech in energy management and with a minor in climate change technology. After that, I worked for a few years in India, mostly as a researcher in the data analytics and energy sector. After that, I moved to Singapore, where I worked also around the use of data and analytics in the renewable energy sector, specifically in photovoltaics. And there I saw that a lot of data is being collected, both from private and public sector, including by students, researchers. But we are not really able to the best of their abilities, make decisions based on that. And I felt that I also do not have an educational background in this. I was doing some things, but yeah, I had this thing called imposter syndrome, let's say, which is more like, am I actually doing it the best way possible? And is it really the optimized way of doing things? So I decided to move to Netherlands to pursue my further studies. So I did a professional doctorate in data science from Eindhoven University here. And after graduation, I decided to continue to work in the public sector. So I joined World Bank as a data science consultant. I've been working as a consultant and also advising a series of projects at the World Bank and also United Nations for past 4 to 5 years. And then when we started this institute last year, yeah, Robert and Professor Dick asked me to join as the lead data scientist slash CTO to mostly manage the data science projects and also understand what kind of use cases are available within the public sector for this. So I work 3 days for ABW, and rest of the days I still continue to consult. And in Eindhoven, I live with my husband, and I have a 7-year-old son who is actually having autumn holidays now. So maybe you see him running around somewhere here during the lessons. So this is me. And today we are going to talk a little bit about a platform, open source platform that we have developed and how we can do this in using geospatial data. But before that, I would like to ask all of you a question, because we are coming from so many different countries, so many different regions around the world. So how many minutes by walk does it take for you to reach the nearest healthcare provider? So you can either join Slido here, or I will ask Martha's help to post the link in the chat. Perfect. I can already see some results. That's good. For me personally, I live just next to a general practitioner, which is like we call it the GP. So it's less than 10 minutes for me. But it's not the same. I am sure you can see it from this. By walk, not by driving or by taking public transport. I would like to know by walk. Thanks, Martha. 20. I'm still waiting for a few more results. Let me hide this. So you can see there is still some variability. So for many, it is for 38%, it's less than 10 minutes, which is great that we are all living in areas with a lot of physical access to, let's say, healthcare centers. And I am not really talking just about hospitals. It can be a clinic, it can be a midwife practice. So yeah, it was a very broad question. And you can see 46%, it is between 10 and 30 minutes. Now let's put this in our mind, or keep it in context, and see in Timor-Leste, this is a publication which was in 2016, not very old, but here they say that in some cases, in certain remote areas, they have to travel 9 to 11 hours to reach the nearest health post. And this particular publication was eye-opening one for me. But also, at that time, we at World Bank approached us to do a particular project on geospatial accessibility. So what they wanted to do is they wanted to understand what percentage of the population have physical access to healthcare. See, physical access is not the same as financial access. It's not the same. I totally agree. But this study focused entirely on physical access. So is there actually healthcare provider located within certain travel times. So this project started like that, or this open source tool started like that. And we see that this is not just in healthcare, but there are a lot of other questions like, what is the access to all season roads? What is access to clean and safe drinking water or schools? So the physical access is not just for hospitals, but this have much beyond more applications across the sustainable development goals. So how did we start this project? We started by first getting the official geographic boundaries, because this itself is a problem in many country contexts. Like, we do not always get access to the official boundaries. So this is where we started. We then looked at all the location of existing hospitals or clinics. So you see all of these plus is actually a healthcare center, a clinic, or a hospital, or a health post. It could also be a community health unit. So we overlaid this, and this information we received from the Ministry of Health, but we also augmented this with the OpenStreetMap data. So we looked at what is openly available. We also looked at what was in the official data sets. We then realized the last census in Timor-Leste was done many years back, and it's not really a true representation, let's say, of what is the population available in that particular year where we wanted to do analysis. So we looked at all the openly available data sources out there. So we found one, which is a World POP. It is a research initiative by the University of Southampton, and it maps population across the globe. And it's available at a pretty good resolution. So 100-meter resolution, or even Facebook have a data set which is 30-meter resolution of the same. So we have a gridded population data. So within each of these grids, you know what is the number of people who are living within that grid. And please keep in mind that this is an estimate, and this is based on some research publications. So we decided to use this. So what we did, we know the location of all the hospitals. We now know the population densities in Timor-Leste. So for each of these grids, so as you can see, it's actually grids. And within the grid, this is colored just by the number of people in that location. So we had these two data sets. The next question is, let's say I draw a circle around this hospital and say everybody within that have access within the 5-kilometer or 10-kilometer radius. But the problem is accessibility cannot directly be just measured by travel distance within a buffer, because roads could be in different conditions. There may not be any roads in that region which are all season. So in Timor-Leste, this was a issue as well. So only 8% of the main roads were in fair condition, with the remaining 22% were poor and 70% were very poor condition. And by condition, it just means that how they were constructed, but it also is that maybe in heavy rain, it's not available, or there were frequent road closures, there were frequent landslides. So also, especially in mountain areas, having a healthcare facility is not enough. You really need to have proper travel infrastructure to reach there. So we were not able to get a realistic estimate of the road network there. So we reached out to one of the Ministry of Transport had a team who was collecting data on road assets. We also looked at the OpenStreetMap data, where they had available all the road network. It is also a crowdsourced, openly available data set. So we looked at that, and we were able to create some kind of a road network data. Now, here also we had some challenges, that we knew that there is a road, but we don't really know what is the surface type of this road. So, for example, is it an asphalt road? Is it a mud road? Is it just a residential road? So we didn't have exactly that information. So when we give these recommendations, we also keep that in mind, that we may not have all the information on road, which is actually helping us make the decisions to optimize the location. So with this, we were able to arrive at this map. So what this map shows is that in red, all the population that do not have access within a maximum of 10 kilometers. And you see here in these cyan dots are 2 kilometers, then the purple one 5, and the blue is 10. So you see here, like at different travel distances, what percentage had access. You can very clearly see on the map, like who don't have access. Now, this is just for visualization I have put here, but we also had like, sorry, I did not know what is happening. Let me check. Yeah. So we also have data on the percentages. So within these travel distance, travel time buffer, what is the percentage of population that have access? We also can overlay other things like multidimensional poverty indexes. We could look only at rural access. We could compare it with urban access. So there are a lot of variations possible with this. But this is the first result that we have. So this is more descriptive. So it describes as this, what is the access levels. What we did next is we applied an optimization algorithm, and you will learn more about optimization and how to write this algorithm in the later session as well. But what this model tells you is, if you add 5 more facilities, for example, you can go from 65 to 77% access. And it tells you on a map where should these 5 or 10 new facilities be added. So these blue are like not existing ones, but new ones that can be constructed. And this is basically the optimization result. So you can go from descriptive to actually telling or giving a recommendation on what is the next step that government or the nonprofit should take to increase the accessibility. Now, what we realized is that for PISA as a tool, so we developed this as an open source tool. So all of you can now go to GitHub and see all the code. Today, we will also go through a hands-on exercise doing this. But what we realized is that there were so many different applications for this, and many people can actually use these because geospatial data is becoming more and more critical in this sector. And sometimes what happens is, let's say today this is the road network, but suppose there is a flood or there is a disruption in the network, you can basically remove, let's say this road is affected. So you can basically remove this node and see what its impact is on the population, but also you could see which are the areas that are not affected and how we can route the traffic, or how you can place centers for, it can be for relief or anything during a emergency response or a disaster situation. So you can rerun this analysis near real time and able to quickly descriptive analytics and optimization at scale. Now, when we talk about scale, Timor-Leste was a really smaller country with a smaller population for this kind of problem. But then we realized it's not just also about all these data science. We had to do like on the ground training. We had to go there. In some cases, there were internet issues. We literally had to print maps for accessibility and catchment areas. So we did a lot of outreach as well on top of this. We also publish very frequently towards data science. It's a data science blogging platform. So all of this are about how we can implement this in different situations. And the code is also available along with it. But we saw that, okay, there is a lot of researchers who is working on it, and nonprofits were able to easily consume these analytics. But if a new use case comes, how fast we are able to replicate this analysis became also important. This is where our private sector partners helped us to develop this as a tool. There is a user interface, so people can just drag and drop data sets and they can build the optimization or build the analytics. So basically, PISA is actually a open source tool that is because of a collaboration of 3 partners. So we have nonprofits who continuously improve the tool by adding new use cases. We have researchers who actually work very hard on adding new functionalities. And we have private sector partners who help us with deploying it at scale. And when we started with Timor-Leste, we received another request from World Bank. This is for optimizing stroke care. So in Vietnam, stroke care was a problem. They didn't have a lot of stroke specialty hospitals. So problem there was, where can we have, which of these existing hospitals should have new stroke care units? So we had a lot of challenge with this use case because Vietnam is much bigger, more population. So our optimization model was taking 3-4 days to run, which is actually not good and scalable. So we had another researcher who was working on building a heuristic model for it, which was able to make it run very, very fast. So we kind of upgraded the model to make it able to consume larger amounts of data. So that is also using Python. It's an optimizer based on Python. So that's also openly available. Then with World Health Organization in Nepal, we use this particular tool for building COVID test labs, scaling up and scaling down of COVID test labs in Nepal during the pandemic. And what we saw is that we needed information not just on existing network of labs, but we also had to look at, can we actually send samples from one lab to another based on the testing capacity itself? So let's say there is 10,000 samples in this lab, but this lab is going to get a backlog. Can you actually coordinate with the next lab, or can you do send it to another lab to get a better, faster result? So why I'm giving these examples is to show that as a tool, it can accommodate different configurations. It is not always that, yeah, you are going to access the location, but you could consider, for example, in Nepal, we considered only relative wealth index as an indicator. So we gave weights to make sure poorer population have access to, let's say, more public labs, whereas we tried to look at areas which had a lot of private labs, and yeah, those areas does not need new deployments because there were already a lot of private labs existing. So it's very very adaptable to different use cases. Then with UNEP, actually this was a project from last year's fellowship. We had a student or a fellow who did a project using PISA. So what they did, they wanted to do is deploy waste or garbage collection cans within one of the biggest slums in Kenya and in the world. But there the problem is, you don't just put in garbage collection units, but you have to have a truck which goes and collect the garbage as well, right? So there was a routing problem as well. So it's not just location problem where you decide location, but you also had to do routing. So what is the time slot that is required for a truck to go and collect it, and which route the truck should take? So it had a lot of additional questions on routing. And this actually gave us an idea to include routing also to PISA. And with this, we work together with AMREF. I'm sure we have a few colleagues from AMREF also in the fellowship. So what we are doing with AMREF is we are helping with the mobile vaccination clinics and its routing. So which villages should it go? In the village, how many people can you expect? Kind of predicting. But it's also that the mobile unit have to then come back to the central repo for restocking, right? So it's not that you go with a vaccine, mobile vaccine clinic to all the villages and then come back. You have to make a few trips back for restocking and others. So we are also doing that with AMREF. And this was also one of the fellows project from last year, and she continued it afterwards. It's with the Netherlands Red Cross 510 team. So we did accessibility to bore wells in Sudan. So we optimized where should these bore wells be placed. But that is also a different question in the sense you have to consider other additional data sources. For example, the topography, the soil quality, the water quality. So there were a lot of additional data inputs required to say you cannot just put a borewell anywhere, right, on the map. So you have to look at potential locations in a much more sense than in the other use case. So we have all these different tools where we, all these different use cases and applications where we can use a similar analysis with geospatial data and mostly with openly available data, but then augmented with official data sets as well. I have a Jupyter notebook exercise where we are going to implement some things. But before that, I would like to hear if you have any questions.
Yeah, so there is some questions. Well, one mainly is about if we can share the GitHub repository for the PISA project, which I think it was what you were talking about.
So we have PISA tool in a separate GitHub repository, but all the slides and the notebook that I used for today's class will, of course, be in the Academy repo. So that will be updated right after this class.
Okay. And then there was a question that asks, did the 510 project also use PISA?
You mean the last one, right? The borewell accessibility? Yes,
I think so.
that's correct. Actually, that paper is right now, the work is almost completed and we are working on the publication. So I can send you the publication once it's ready.
And then there's another question that just came in. Have you used ArcMap GEE or Python for the analysis?
We use Python for mostly all of it. And some cases we see that the OSM data may not have a higher accuracy. Then we might decide to go for example, Mapbox or here or Google API. But that is very use case specific, I would say. Depends totally on the country context and whether we have, for example, budget available for doing it. Because Mapbox have actually 250K or something free, openly available token, so we can easily use it. But Google is not the same. But we always do a sensitivity analysis. So what we do is we will calculate the percentage of population with access using Mapbox, using OpenStreetMaps, and using Google Isochrones. We have a few other tools as well, like here, HERE. So we do a sensitivity analysis to see, does it actually make sense to use one over the other, or we can just go with OSM. But it's not always straightforward, because in Nepal, we used Mapbox. Timor-Leste, Vietnam, we used OSM. So yeah, it's very variable across use cases. More questions?
I think there are no more questions in the chat.
Sorry. So the geographical data changes from time to time. How do you tackle the updates?
So you mean the healthcare data, all of this changes over time? How do we take care of this? Is that what you mean?
For example, a new flood happened, it destroyed a bridge, or a new development to a road, it made it better, etc. This data, is there like live updates for that, or how do you tackle this change? Because what is relevant in some specific time might be not relevant after a while.
Yeah, totally agree. So PISA is basically a toolkit. The data behind it can be your own data. It can also be OpenStreetMaps, or it can be WorldPop, because WorldPop updates every year. OSM updates whenever there is an update, let's say by a contributor. So, but in most of the use cases, in near real time or disaster response, like you asked, they use their own data sets for this. They don't use the openly available data. For example, roads, you can there are a few initiatives which maps flood affected areas. So basically you can remove those road network and rerun PISA again. So PISA is actually not data dependent, I would say. It's just an openly available toolbox. So you could run it with your own data as well. I have maybe a question for you. Can you think of maybe a few other potential use cases for PISA? It could be from your line of work. How to use secondary?
I can think of like for us in WFP, World Food Program, we assist beneficiaries with a e-card. And we have some contracted shops and as well as ATMs that beneficiaries need to get their assistance through them. So instead of access to hospitals, his access to the service could be very good, like use for the PISA. As yeah, and we have the in-kind as well, especially in wartime. Sometimes people need to travel. Actually, in other countries, they need to travel, or even in Lebanon, we had this problem where we really care about providing assistance with the most dignifying way for the beneficiaries. And we study the way that we can give them our their assistance without making them, for example, carry it, or if it is heavy, how can they travel? How can we make it more easier for them to be able to access the assistance, whether it is in kind or through the cash-based transfer.
Yeah, that's a really good example. Thanks. Mohammed, you have your hands up.
Yeah, I'm also working for WFP, and I think I have some potential idea which I will consider applying in. I'm talking now from South Sudan, and in South Sudan, I'm part of the nutrition team where we are assisting around 1,200. We have around 1,200 sites providing curative nutrition services. Just as a background, curative services, like the nutrition treatment is a costly service, which costs around $55 per beneficiary, which is like a huge amount if you think about the whole caseload. One of the problems that we face is that the distribution of our sites is not always adequately distributed, and we are facing a problem of what we call it double dipping, which means that some beneficiaries, let's say a mother has a child, and the mother will register the child in 3, 4, or more than one site, and then she goes from a site to another collecting assistance, and every site think that this child is here. So this is a major compliance issue for us. We tried actually so many ways to to ensure that we don't have that duplicates. One of the measures that we took is to run all the sites in one particular day, like just to probably make it a bit more difficult for one person to move from one site to another. In other scenarios, we used we mark whenever a child gets service, we mark their their fingers with some ink or something. But I think now what we can do with plotting all those sites geographically, we can reconsider the distribution of those sites, and we ensure that we have like enough distance between those sites. That first, we don't keep some places underserved, like because sometimes we have huge areas that they don't have access, near access to some sites, while in other places you have multiple sites near or next to each other. I think that would be a good idea. So we can map them. We ensure that we have good distance between them to avoid this some sort of double dipping.
Thank you. That also sounds very interesting use case. And I would like to point out one thing, that the data is usually the biggest challenge, I would say, because let's say we had this particular initiative where we wanted to see whether farmers have access to markets or warehouses or storage locations. But it is so difficult to get, for example, farmer boundaries, or in smallholder farmer situations, or to exactly know where are these farmers located, what kind of crops do they generate, to actually make sure they need warehousing support to actually build the optimization model. So while PISA is actually a very strong tool to help you in visualizing data or in doing the optimization and the modeling part, most of the initial work is more on data pre-processing and making sure that we have the right data sets to feed into that algorithm, because otherwise the decision-making process cannot really apply the results directly into the context in which the problem you are trying to solve. So yeah, I really want to make that very clear. When we think of use cases, we need to try to also come up with innovative ideas sometimes to figure out the data inputs as well. So I see a few comments, but I would like to go to the notebook because I really would like to go slow on this, because this is the first geospatial session and many of you might already be working with geospatial, but I will assume that all of you are beginners. So I would like to go really slow there. So I would like you to open this notebook in the link. I didn't share this in advance because there are some API keys which I don't want to share it. We will just go through the session and I will, after that, you pick up. If any of you have any issue, please let me know. Please don't make any edits here, but click on file and save a copy in Drive. So basically you will create a copy in your own Drive and please open that. Because I would really like both of us to do it together, because I also would like you to start implementing things. You don't need to understand all the code, but you can just click on save a copy in Drive, which will open a new Colab notebook for you. So it will have a new name. You could give it another name, whatever you like. And please don't edit in this one, which I will be running. Let me see. Stop sharing. All good?
I see you use the HDX of
Yes.
the UN exchange. Sorry,
Yeah.
your UN exchange language. Yeah, so you can be able to I don't know how to say it, the word, to get keywords for specific like columns or definitions of data.
So yeah, Humanitarian Data Exchange is also an open platform where you can get access to a lot of data sets. So yes, I do use that. And it is good that you learn this because it's not just for healthcare data. You can actually access a lot of other data sets. So you could reuse the API for that as well. Okay, so we are going to the first cell. So I will call this a cell. But this is basically installing some things which are not in your Google Colab environment. So you probably have to press this and run this. So you can run this cell first. And this cell is basically importing all the required packages for this. Please don't worry if you don't understand each and every line. That is not the goal for this session, because this session I would like to show you more about how to apply these things. So you get an overview. Then tomorrow, I think tomorrow, Britt have a session where she will show you specifically how to handle different types of geospatial data. She will show you how to visualize geospatial data. And also then later on, we have a session on optimization. But in this session, I would like to give you a really good overview of what is possible, what is not possible in this, with the things that we are teaching, of course. There are other things which are possible, of course, but only for the overview for this session. So this takes a few minutes to run. That's fine.
Sorry, I received some errors while installing the HDX.
Okay.
I think spare dependency resolver does not currently take into account all the packages that are installed. Its behavior source following dependency conflict. Looks like there is a conflict in the version between TensorSoft and HDX.
Do you still see you must restart the runtime in order to use newly installed versions?
I will see.
Okay, let me show you this. Do you see this?
Okay, okay.
So just restart the runtime.
Thank you, thank you. Do that.
Yeah, no problem. Once you restart this runtime, you don't have to run this cell again. It just restarted it to make sure everything is there. And then you import this. So just run this cell. You could use this one. So you could run the cell, but you could also use the shortcut. So whatever you prefer. So you run this cell mostly for importing all the packages required for this notebook. Now, the first data set that I would like to introduce to you is something called GADM. It's a Global Administrative Areas data set. I just use this for this purpose because it's just openly available. You could use your own administrative boundary data that you have in a geospatial format, but for this, I have just used it because it's globally available for any country. So what this data set, what this does is, it will call the GADM downloader. Here you can give any country name, and you can tell at which administrative level you want. So administrative level 1 is usually districts, provinces, 2 can be municipalities, but it also depends on countries because different countries have different names for these. But you could give here 1 or 2, or some countries have up to 4. So you could choose any country here. You could type, for example, Vietnam, you could type Kenya, any country. I am for now just writing Timor-Leste because that's what I would like to discuss with you. But I would say for this analysis, you could run your own as well. If you would not like to do it for Timor-Leste, do it for another country. I'm perfectly okay with it.
Excuse me, can we use the ISO code? Because sometimes what I notice is that across different data set, the name might change, but the ISO code is going to be always the same, no? Like Tanzania is called the Republic of Tanzania, stuff like that. So maybe the ISO code is better, no?
Yes, I do agree that sometimes it will be different, but you could go to GADM. If you have trouble finding the data you want, you could go to GADM and check the Python developer portal there. So they will clearly tell you what name to use there. But for now, you can use Timor-Leste if you have any error. That's perfectly fine. I stopped sharing because I wanted to see you, but now I'm going back to sharing. But here I would say use 1 because if the administrative level is too big or the names change, then it might be a problem. So just use 1. What this does is it just gets you the shape based on the country name you have passed. So basically, this is a function. So it takes as input the name of the country that you passed here and the administrative level, and it gives you a data frame. And the data frame will have the name of the country, the name of the district. It will have the polygon, like the geometry, the shape of the boundary. So I will show you Timor-Leste, and it will tell you that it is downloading. So it's tick, which means it's done. It's 100% done. This is the data frame. And here I just made a map, so I can easily show you how it looks like. Please do execute cells with me. So if you see any error, please let me know, because others might also be getting similar errors. We could figure it out together. Oh, my connection has some error. You have an error, you say? What is the problem, Ismail? Hello? Hello?
Yeah, we can hear you.
Yeah, I think it's okay now. Okay. I don't know what happened. Mm.
I guess she just thought the problem
Yeah.
lies with her and her connection.
Yeah.
Guess she's reconnecting.
Mm.
Hello, can you hear me?
Yes, we can hear you.
Sorry. Martha, can you let me share my screen?
Yeah. Yeah. Okay, you should be able now.
Yeah, do you see my screen?
Yes.
Okay, so I think we were here when I lost you. So we give the name of the country. It downloads the administrative boundaries, and here we are basically visualizing it. So what we did do here in this code is we go through each of this. So this is ALU district. I'm going to visualize this polygon. Then we have another district, and we are visualizing this polygon. So basically we are iterating over each line of this data frame. That is basically what this means. You iterate the rows, you iterate through each of the rows, and you visualize the boundary. So this is the shape. And I have given here a pop-up. Basically what the pop-up means is I click on this, it gives you the name. So I have added for each polygon the name of the district as a pop-up. So that is basically what this code snippet is doing. It is initializing a Folium map. So this package is Folium. It is iterating through each of these rows in this data frame. So row 1, row 2, row 3. And then it is visualizing it. It is converting it into a JSON format, and it is visualizing it. It is filling it with orange. So this is the fill color you see here, light orange. And then you add a pop-up. I'm adding this pop-up to this map. And M is basically the map. So it's visualized here. Now for ease of access with running this and making it faster, I'm going to pick up one of the particular locations to do the analysis. So I'm going to say I want to select this particular administrative boundary. And I'm going to say I want to select this. Then this selects only that particular selected administrative boundary here, and it will visualize it. So I'm going to do that now. So you go here, you zoom in, you see all the others are a particular color, right? So it's the original map. On top of that, I say I want to select this. So selected boundary, and I made this into orange. So basically I have just added that, and instead of, from the orange, I have just filled the color as red. So I added that just to show that we are selecting this. Now, visualization becomes also very important in your storytelling, because geospatial data, especially, it's easy to tell a story if you are able to visualize it. So in Brit's session, she will really drill down into visualization, how to do it using Python. But here I want to show you like how easy it is to explain when you actually have maps. So I have the whole of Timor-Leste, and I'm only selecting this for this particular analysis. Now, like I said, population density is something that not every time we have up-to-date information, especially through census, because census happens census does not happen every year. In many countries, it's once every 5 years, it could be once every 10 years. So having accurate population density maps is very, very important. So I have added here about one of the data sets that we have used, and it is available in Humanitarian Data Exchange openly for any country that you would like to look at. And this code, what it does is it takes the 3-digit. So there, every country have an ISO code, a 3-letter code. So for Vietnam, it is VNM. For Timor-Leste, it is TLS. So if you have another country that you would like to run this for, you can give the 3-letter ISO code here, and you pass that to this particular function. So what this function does is it goes to the HDX site. It uses the HDX API, and it downloads the 2020 population data set. So you could actually, if you have another recently available data, you could change these. You could get another data from HDX. So you can actually reuse this code to get data from HDX for any other information as well. So what I'm doing here is for Timor-Leste, I'm getting the population from this meta data set, and I'm setting its CRS. Then I'm going to print the total population for Timor-Leste. And this will be, so it says that the data is downloaded and the total population is this. Now, this is for the entire Timor-Leste because I gave it only the ISO 3 code. And this is the data frame. So what it have is, it have a X coordinate, which is the longitude. It have the Y coordinate, which is the latitude. And in that point, what is the population? And you can see here, since it is an estimate based on a machine learning model, these are not really round numbers. You could round it later on. But this is a question many of the students ask, but this is because it is a machine learning model that is giving you these population counts. And it is also corrected to, for example, the population census, the United States nations data. So this is, you can read a lot more about this. I have added the links as well here. So how this data set is created and how it can be used, you can go and check the website as well. So this is what we have now. So we know the administrative boundary and we know the population. Now, what I do is, like I said before, I want to do it only for one district. So this code basically just extract from this data frame only within that administrative boundary. So you are joining two data sets, the administrative boundary and the population data, and you are extracting what is within. So just to give you a feeling of it. So basically you have, for whole of Timor-Leste, you have points, lat, lon, population. And then I basically extract only what falls within this boundary. If you want to analyze for whole of Timor-Leste, you don't have to do this. But if you want to extract for any administrative boundary, you have to run that code. Okay, and then I see here, what is the area of interest? What is the population? So this is the total population. Yeah, Martin, you had a question? I cannot hear you. Is it me or?
No, I think we can't hear Martin. Or I also can't hear.
Can you hear me now? Or
Yes, now we can.
okay.
Thank you.
Yeah. So maybe I missed it, but I just wanted to ask the granularity of that population density data. So it's on, because if I look at the X and Y coordinates, like, yeah, maybe you can zoom in on that a bit, like how to, on which level it's recorded, the population density.
I think it is 30-meter resolution, but it also is available at 1 kilometer. So I will also check with you. So this is the Facebook Data for Good initiative. So if you go to here, you can actually, like I said, see the methodology, and then you go to HDX, the Humanitarian Data Exchange, It explains like the format, and if I remember, it is 30 meters resolution. Yeah. But it is in
Okay, so it kind of sums the data within that square and puts it on one data point. Yeah.
Exactly. Yeah. I cannot. Yeah, go ahead.
No, and I was just wondering, like, what does Facebook have to do with this? Like, do they base it on their user data, or is it just some separate initiative that they're doing?
It is not based on Facebook data. It is based on satellite imagery, and it's based on UN population estimates. So it is actually just their data for good. It's a separate initiative. And I really would like to add that there is also another data set, which is also really nice. This is maximum is 100-meter resolution, World Pop. I will post both the links for you to take a look. This also, if you look at the data, you have many other data set as well. But if you go to population counts, you can see, I usually go for the UN adjusted numbers, but the maximum is 100 meters. But for the meta data set, it is 30 meters. But here also, I would say, Martin, it's good to do sensitivity analysis, because whenever we submit a result or a report, we say using World Pop, this is the results we have got. Using Meta, this is the results we have got. Using Census, this is the result, because it's very, very important for the decision maker to know what data it is based on, and they can actually choose. If the results are so different, then yeah, it is really bad. You have to do a better data collection exercise for it. So yeah, that's something I want to clarify. I'll post this. And Francesco, you had a question?
Yes, thank you. My question is if you can post the link of this data source, because I'm trying to modify the code to read South Sudan, so SSD, but I'm getting an error. So maybe South Sudan is not there in that website, or maybe not in 2020. So I want to check what is the latest year available, so that I can modify the code accordingly. Thank you.
I have posted the link, you can check there. But if you are facing an error, I would say it's really nice to see for the country that you do, at least the total count of population. But if you are getting an error at any point, please just revert to using the Timor-Leste data. That is something that works. I have tested it.
Yeah, no, it's okay, it's okay. I mean, I will try if one manager will use Timor-Leste. Thank you.
Thanks.
Okay, mine is a quick one. How do you get the country ISO index number?
World Bank actually have a data set for that. So it gives you the list of all the countries, the ISO 1 code, ISO 2 code. 1 does not exist, sorry. ISO 2 code and 3. So you can get the list there. I will post that link as well. But you could also just
It's okay, it's okay, thank you.
So for example, 3-letter ISO code, you could just do this. It's a globally accepted way of naming convention. So you could just Google it. It's usually correct. So that's also possible.
Okay.
Yeah. Yeah. If you have any questions, just unmute or raise your hands. It's perfectly fine, because yeah, I think it's also not just helpful for you to get answers. Maybe some of the other fellows also have similar questions. So yeah, please go ahead. That's perfectly fine. So I will move on for now. So we are here. So I have extracted the data from Timor-Leste, which was 2.67. I have only extracted for the area of my interest for this particular exercise. So you see here what is the and I have just named it AOI for area of interest. So this is the population that we will be looking at. Now, doing travel distance, travel time calculations is very, very compute intensive, and many cases cost intensive as well. Because for every population point, if you have to calculate to the hospitals, you can imagine for big countries how many times that call have to be made. So most of our applications, we try to use something called isochrones or isodistances. So before I explain this code, I will show a visualization. I don't know if that's there. Yes. So I will show this particular visualization. I will explain the code after this. What basically isochrones allow, or isochrones or isodistances allow us to do is, let's say there is a hospital. Let's say this is the hospital. Isochrones and isodistance calculations using either OSM, Mapbox, or here, all these APIs, what it gives, and OSM is totally free to use. That is the exercise I have used. Basically, it gives you the polygon around it for different travel distance, travel time thresholds. So it can be 30 minutes, it can be 60 minutes, it can be 10 kilometers, it can be 50 kilometers. So there are two metrics. It can be either travel distance or travel time. And it have different modes as well, walking or driving. It can also be, in some countries, it's available by like walking by foot, cycle. In some ways, sometime it is also available transit. But the problem is like public transport, but the problem is it is not same for every country. It is not available uniformly, but travel distance, travel time ranges for particular food and walking, like walking and by driving, is available throughout in most of the cases. There is a question. Like K nearest neighbors. Yes, isochrones, actually how they calculate it is little tricky to explain. But tomorrow, 18th session, we will do a shortest path calculation. Professor Joachim will teach you. But what this isochrone mean is, it is not these points. Please ignore these points for now. Basically, it just gives you around this hospital, what is its catchment area. And that catchment area can be at different travel distance, travel times. And if we have that, then the code becomes easier, because basically you just need to calculate the population that falls within this polygon. Let's say this isochrones or isochrones does not exist. Then what you have to do is, let's say this is the population point. You have to calculate the distance between this point to this point, this point to this point, this point. So for every population point, you have to calculate the distance to the nearest hospital. And the same way, you have to calculate the distance to this point as well, because when you start, you do not really know how many of it can be accessed. So it's extremely computationally, it takes a lot of time in many cases, especially when we work with Vietnam. It was taking like forever. So do spatial join for each. Yeah, exactly. So first you do the polygon, then you do the spatial join. So what it means is, first, if you have the polygon, you can just calculate what are the points that are falling within it. But this also have a challenge. Suppose you want to know the average travel time for all these points. That is a bit tricky, because what isochrones tell you is, within 10 kilometers, this is the polygon that have access. But outside that, we do not really know how much time it takes for this point to access it. Or you do not know which point, how much time does this point to access it. It just says it doesn't have access. So based on your question that you are trying to answer, you need to decide whether you go for isochrones or whether you have to look at travel distance calculations. And if the idea is to go for travel distance calculations, then there is something that we use in Python itself. So that's also in the GitHub repository. But for today's workshop, we will look at isochrones and isodistances. So I'm going to explain this code. Before that, let's look at this. So first we need to look at where are these hospitals located. So we have now the population, but we need to also download the data for hospitals. So how do we do that? Is using something called Overpass API. So Overpass API allows us to download data from OSM for any country. So here you see, this is the problem with all these different APIs is, GADM uses the name of the country, population uses the 3-digit ISO code or 3-letter ISO code, but OSM uses a 2-letter ISO code. So you really need to figure out how to use these APIs to come up with the right set of things to get data. So like I said in the beginning, getting the right data in the right format is usually the biggest time-consuming exercise in this whole thing. So what we are doing here is we create a query to the Overpass API, and it downloads all the list of hospitals. That's what this code is doing. It creates the list of hospitals because I am here giving like amenity is hospital. And I want to tell you that OSM does not just have hospitals. For example, if here, instead of asking for a hospital, here I'm asking for a clinic. So this code is exactly the same as above. I'm querying the Overpass API, but instead of asking for a hospital, I'm saying, tell me all the clinics that exist in Timor-Leste. And OSM does not just have hospitals and clinics and healthcare related. It have schools, it have hotels, it have ATM points, it has so many other data sets as well. And it's a crowdsourced data. And this is also something that I encourage a lot of my students or people from public sector to do is, if you have some time to do additional volunteering or for your professional, if you would like to really contribute back to the open source community, I would say for your country, do some mapping exercises, because for many countries, this data is not comprehensive enough for analysis. And that's something that we are seeing recurrently. And as people who are working in this sector, anybody can contribute to this, and it's relatively straightforward. So even though this data, you are able to get access to it, it's always good to know that this is crowdsourced, and you might need additional data, official data sources to actually strengthen this. I think we have look for specific clinics, for example, clinics with a specific name or managed by a specific organization. Specific name, yes, definitely, because it have name. Managed by organizations is something I am not 100% sure because I have never used it. But if you go to OSM tags for hospitals, so here, if you go to the OpenStreetMap wiki, so similar to Wikipedia, it have a wiki for OpenStreetMap. I will put that also in the chat. So here it tells you what are the things that they data sets that they have. So you see here, it has something called operator. So it does have a name of the organization which operates the hospital. Sorry. Okay. It does have like if the operator is a private or a government organization, or it's a religious or a community organization. But I would like to say that these are not compulsory fields. So in many cases, it might be, it might be just empty. So it is always good to look at the amenity hospital or I've just used the Overpass API here because this is the easiest one to explain. So I have just used the Overpass API here. Oh, thank you for sharing this. This is really good. But I would like to say that this is not really like a general wiki. This is wiki for the OpenStreetMap platform, because they do a lot of community changes here as well. So you could really use the information from here for your API as well. So for example, if you would like to know what tag should I use, what is the name of the amenity, all of these things you can just give here and it will give you the downloads. Okay. Then we have the name. I extract only the name. There are a lot of other fields as well, but here, just for simplicity, I have extracted the name. Yeah, that's also, yeah, if you just want to know clinics, that's also perfectly fine. And you basically you have two data frames here. One is the hospitals and one is the clinics. And what I have done in this part of the code is I have just concatenated both. So I've just added one after the other. So I merged them together. And number of hospitals and clinics extracted is 120. But like I said at the beginning, I'm only going to look at Bacau. So in 20, what is only for Bacau. And this is where, again, the administrative becomes important. In the cases, we always try to go for official data sets for the administrative boundary, because when we publish and we have, when we have any important decisions to be made, it's always good to go for the official data. So actually, this is something I also use quite a lot. The data quality is, like I said, it is a problem. But we see a lot of value in this, because when we try to explain that this is a possibility for a particular use case, you also need to motivate people to share data. You cannot just say always data first. You can always say, yeah, you give me data, I can do the analysis. But what we try to do in most of the challenges is, okay, this is the thing that you can do with openly available data, but the quality could be a problem, especially this number. We say that, yeah, in this data set, there are only 120 clinics. But if you look at the official statistics, or if you look at official data, we see there are 200 or 300. Can you please give us the complete list? We run the analysis with much better accuracy, because everybody is really busy in their work, and they it's also a challenge with data science in general is not all data science projects succeed. And people feel in some cases you are getting data, but we do not really see an analysis or an outcome which is actionable. So we use OSM or openly available data as a baseline. What we show what is possible. If it's not interesting or not solving the problem, there is really no need to go and do all these data collection exercises afterwards. So we use this mostly as a baseline. And in many countries, no data is available, then this is, they find this still better to start with. Okay, like I said, here we download the number of hospitals, 120. And from that, I have extracted what is available for Bacau. And this is how the data set looks like. So we have the name. Sometimes there is also another column, which is the English name. So there are a lot of other columns also available. I have selected it here, like ID, name, and geometry. But if you are interested in other things, like you asked, the type of organization, you could extract those as well. Definitely possible. Just add those here and it will be extracted here. Then this code snippet calculates the isochrones, like I said. Let me see. Are you all running the code together with me? Any problems? Errors? Okay, that's good. Then this code basically calculates the isochrones. What it does is, it as location, you have to pass the longitude, that is the exact X. Thank you, Martin, for that, for confirming that. Then we have the Y coordinate, which is the latitude. And this is, because I am using time, this is in seconds, because that is how this API works. So in this API, you have to pass this in seconds. And then I give the range type. Should it be time or should it be distance? Most of the time we use travel time, but it's very tricky to use travel time, because, for example, in Mapbox, they recently published a way, because travel time depends on the time of the day, right? because if you are traveling peak hours versus if you are traveling in the AM, 3 a.m. versus if you're traveling 5 a.m., 5 p.m., which is busy time. So Mapbox have that functionality where you can give an option like start at. So you can give any time that you would like to start, like it can be 9 a.m. or 9 p.m. But in this, we just say time and the time in seconds. So here I give 1800. So here I have put in my key because yeah, it's free to use. But after the session, I will disable this. For now, you can use the OSM key that I have here. But you can go to the OSM routing engine. I have a separate note for this, how to set it up. So you could do that and put in your API key here. No module named Folium. Yeah, it is because you are running it in your local Jupyter. So you probably need to do this. Because in Google Colab, it shouldn't be a problem because Google Colab already have it installed. Yeah. Oh, where was it? Back to, yeah, here. Yeah, so we then post the request. Yeah, I forgot the magic. Thanks. The magic keyword. So you post this request to this particular API. Usually, different APIs have their own format and syntax, but you could reuse. You want to use Mapbox API in PISA GitHub repository. There is a separate code for Mapbox. There is a separate code for here. So depending on what API you want to use, you can just reuse the code from the PISA GitHub repository. But here I have just used OSM because yeah, I wanted to give it open key here. I think a few years back, I put my Mapbox key in a notebook and shared it with another data scientist, and I got a huge bill. So please never do that. It is not good. Of course, Mapbox gave me some options because it was a mistake. But yeah, please never give your API key to anyone except if it's a paid one, which have a except if it's an open one which have some security and 2FA already activated. So yeah, it is
sharing is caring. Sharing is caring.
Yeah, but not if you have a big hole in your pocket, right? Yeah, so you also need to know when to not share stuff. So yeah, so here you have to put your API key and it works.
You know, you can rewrite your history, the GitHub history, so people cannot go back to the history and see if they
yeah, I did that, yes, but it was a bit late.
Yes.
Yeah, Eva, you have a question?
Hi, can you hear me?
Yes.
Yeah. A couple of us are running into an issue in the next cell. Polygon is not defined, so we were wondering where we should have defined polygon.
Is it in Colab or?
Colab, yeah.
I think Parvathy, if you run it, you might also have the same issue because yours is also underlined.
Yeah, that's exactly what I was looking at.
Yeah, it should have been in the import part, right? Yeah.
See, I have a local copy. Just give me a second. Yeah, you can put this. This should work because you already created a copy. You may not be able to see it, but try this. You should not be having an error. But this is not the same error. Huh? This is a different error. But the polygon is fixed, right? I think they are all using the same key. And they have a rate limiter. This is not good. Let me fix it. Not good. But polygon error is fixed, right? So now you are getting the rate limiter, right?
I get one saying features. Key error features.
It means features is not available in the data frame that you are dealing with. Or
Yeah, that is actually the same one. Yeah. No, I still have it is not this problem. It is the API error. Let me give it a shot. Yeah, so let me fix this. Yeah, it is a problem with this API, but I still have tokens. I do not know exactly why. Maybe because it thinks that there is there are more people accessing it. And it's kind of like a spam filter for the API because yeah, their server also should not get overloaded. So this particular error is a key error, and it is not able to extract the features because it says that the rate rate limit is exceeded. So what it basically says is this particular API key, more than 50 of us are using it at the same time. So it could be that they have a spam filter in place, which is protecting the code from running. See, it is now working fine because the let's do it with these three because the three is working fine. Okay. Let me explain what we need to do because I also don't want to waste your time. So what this returns is it gives you this particular gives you a request to this open route service. And for the profile, which is driving by car, because that is basically the profile that I have asked here. And for the latitude and longitude that I pass, which is this location. For the range time, this is seconds. It gives you the polygon. So it gives you a box. This is not the polygon. This is the polygon. So the geometry coordinates. So it gives you like a polygon, which is a boundary, like I showed in the previous map. And you now know within this particular catchment area that you have defined here, by driving, this is the area that falls under it. Now, what I have done after that is just extract all the population points that are within. So that is here. Yeah. If you look at this volume map, and you can rerun the analysis later on. So you have a point. This is the lathlon that we passed. Then it extracts the polygon around it. then the code that is in the same cell, extract all these green dots that are within this, which I colored as green, and all the red dots are colored, which means it doesn't have access. So what this code snippet does here is exactly that. So I add a folium marker, which is the location of the hospitals, and I color it blue. Then I add the catchment area that also I colored as blue, the catchment area of around each of the hospitals. And I added a pop-up. So you click on these points. It gives you like a pop-up, right? You could also add titles, name. You can make this interactive. So there are so many things you can do with this map. And if I click on any of this, this is also another pop-up. So I created the pop-up for that. And I added it to the map. The same I did for population without access. I made all of that into red. So that's where you see all the red markers. And population with access, I have made that to green. So that is how this particular map is created. Now you have this map that is a good one, but you now need to know how many of these population have access, like a percentage, because that is usually what you are interested to know for a particular area. And you want to know what is the percentage that do not have access. So this is where the descriptive part of the analysis stops. Now the optimization part, Professor Dick is going to cover, Professor Joachim is going to cover later this week. But I would like to ask you, based on what you have heard now, what data do you think, in addition to all this, what we have seen, is required to optimize the location of new hospitals? So suppose I have money as an organization to construct 5 new hospitals, and I want to use PISA's optimization model to place them optimally in the region. I need one more additional data to actually be able to optimize it. What do you think is that additional data set?
Roads data?
Isn't isochrones a proxy for roads as well? Because it is giving you travel distance, travel time as well. What it could be, because the model needs something to actually
population density.
Yeah, but that is already here, right? This is population.
Yes.
Elevation.
Sorry, the elevation. Yeah, that is actually a pretty good one. But the travel time calculation takes into account elevation and slope as well. In many cases, it should take into account.
Yeah, areas where health facilities can be located, because they can't exist existing buildings or something like that.
Yeah, exactly. So potential locations, because the model doesn't have any idea where these locations can be, right? So how do you actually decide? You have to tell the model, these are the 50 or 100 locations that are possible. From this, tell me optimally where should I place. So the list of potential locations is something that you can, the model require. But how can we create it? Like using openly available data. Like assume that you as an organization have no data on locations where this, where these locations can be. Can we use maybe some logical assumptions for it? Like for Timor-Leste, how we did it, I will just explain. So we took the whole of Timor-Leste and we divided it into 1 by 1 grid, 1 by 1 kilometer grid, or a 10 by 10 kilometer grid, or a 100 by 100 meter grid. And we decided each of those grid, like the center of each of those grid is a potential location. But does it really make sense? Can you actually, throughout the country, can you place anywhere a hospital? Shouldn't be there some criteria?
It should be residential area.
Yes.
With close proximity to people living.
Yeah, but
it shouldn't be a place where there's already a hospital or something.
Sorry, can you please repeat?
It shouldn't be a place that already had health facility.
Yeah. Other things?
Where already there are buildings or mountain forest.
Yeah.
I think it should be next to a road.
Yeah, that's correct.
Probably the other thing is like to take into account the average of the price of the houses.
Yeah, the cost, yes.
Areas that are not prone to floods or other disasters.
Yeah, that's correct.
There is electricity.
Yeah, electricity, yes.
And close proximity to roads.
Yes, that's correct. So I have few things to add. So not too close to other health facilities and somewhere where population is there, right? These two will already be considered by the model, right? Because the model is going to pick locations which gives more access to people. So it will not be, for example, area where there is nobody living there, right? Because it will look at the population density. So the model is intelligent, or that is how the model is built. The goal of the model is to maximize access to population. So it will be in a location where there are people around and there is a higher density. So that will be taken care by the model. Secondly, shouldn't be next to another health facility. So if you look at these population, they have already access. So what the model, the optimization model will do is, it will look at the red dots and try to give them access and not give double access to these, because they might have already access to a single one, they can have access to multiple facilities. So these two are what we call as inputs to the model, that the optimization model will already take this into consideration. And I'm explaining this because it will make it easy for you to visualize, because optimization can be very tricky subject or a topic. So it's important to clearly understand the problem or the use case we are trying to solve to visualize it. So population and access to access to other hospital are definitely two things the model will manage. But I really like the point about access to roads, because it shouldn't just be residential roads. Mostly, if it's a big hospital or you are going to construct not just a clinic, it needs access, for example, for ambulances, right? And it should also be an area where there is electricity, water connection. So you need a lot of additional data sets to do a suitability analysis to find the list of potential locations. Because definitely this is, how do you say, the optimization model is good or powerful, but it is actually not powerful without the right data set that it requires. So making that list of potential locations is extremely important. Now on flood risk and on access to electricity and others. So I would like to explain one work which we did with or doing with World Bank. So we have this data which is from European so openly. So let's say you can give weights based on these climate risk. You can give weights based on other factors, like there was one comment from someone that you need to do a suitability analysis with different layers. This is exactly what we need to do. But what are the layers that needs to be used depend on your use case. So going to the 510 use case on borewell accessibility, there we had to look at soil data set. There we had to look at data sets such as land use. It cannot be in, for example, natural reserves. There were like so many additional data sets that have to be considered. Now, if you are trying to maximize access for farmers, you need to look at where are farms located. You need to look at access to cold storage, warehouse facilities. So the layers required for doing suitability analysis will also depend on your use case. And a lot of this is available openly. So if you have a project or an idea that requires these kind of analysis, you could always look at open source data first. And if you see that the accuracy is too low or sensitivity is very not good enough, you could always go with official data, and you can start finding official data to augment your analysis. That would be my recommendations for using it. Now, since we had a few issues with the token, what I would really like, I am always available in Slack. It's in my phone. You can text me if you face any issues with the code after the token is done. I will update how to get this particular token in GitHub. I will post all of this immediately after the session. But please do run these 3 cells and see if you get any error. Then just let me know and I will help you fix it in Slack. But with this, I think we are almost done with the session. I wanted to have a lot of time for Q&A. So I would really like to hear from you, your questions, thoughts, ideas. No questions?
Yeah,
You were
it's really
very
nice
clear.
to see a notebook like this and to see how it's done for a specific use case. I think, of course, it starts to get more difficult when you want to apply it to your own. So I think that we'll just need some, hands-on practice. But at least to have some example code, it's really helpful. Thanks.
Thanks, Martin. Anas, I think you were saying something.
No, I just want to say you were very clear.
Oh, thanks. That's good. No questions can either mean it was clear or it was not at all clear. So it's good to hear that it was good. The polygon error, it is because I didn't have the shapely polygon. Please try to, I have added this now to the right link. Let me update that again.
Actually, I still I'm not able to download Isocron correctly. Actually, I get the features issue.
Yeah, so the features issue is exactly because of, like I said, because of the rate limiting. So I would advise you to look at the GitHub repo. I have created I will update Excel, like a Word document, which tells you how to get that API key. I would say substitute it with your own key and you run it. Then you will not face an issue. It is because of rate limiting, the features error.
Yeah, but it's gonna be costly for me.
No, it is free. It is free.
I'm just kidding.
It will cost you time to set it up, but otherwise it's free. Any other questions? If not,
one quick question, please. If you are working in areas which we don't have any kind of population data available on cloud, so we need to connect with another sources of data, like informal camps, for example. So we need to customize the tool for doing this, right?
So in PISA toolkit, I haven't shown it today, but there is a way you can upload your own data set and you can run the analysis. But the only thing is it should have the same kind of structure. So for example, it should have latitude, longitude, and it should have the population. So it have to be a geo data frame. If it is, then you can directly apply it. You don't need to customize it, but it is important that you have the same or a similar structure.
Okay, clear. Thanks.
Is it possible to do satellite image analysis using Python? Yes, there is actually an amazing GitHub repository about that exact topic. I will share it with you, but I think it is not really, not covered in this session, of course. And it is a totally different field, I would say, and very challenging, but so much work is being done there. I can send you, Saraf, a link where you can read more about this. Okay, that's good. Then I would really wish you good luck for the next sessions, and thank you so much for your time. Thanks, Martha.
Thank you.
a lot.
Wonderful.
Thank you very much.
Thank you so much.
Thanks. Thank
you.
you.
Thank you. Bye.
Bye-bye.
Bye bye.
Bye.